Okay, so welcome to Block, the tabletop coding game. And this time we're going to talk about the game and the game structure. Now, this video itself should probably last about 15 minutes. I'm going to go over the essential elements and how to play the game. So, of course, welcome and let's get started. So this, of course, is a tabletop learning experience. And that means you're going to use paper and pencil, which are provided within the PDF or PowerPoint handouts for this particular curriculum. But let's talk about how we're going to go about learning to play the game and what your learners should learn as they play the game. So again, this is the instruction manual, and we will cover the following questions. So what is blocked, of course, and I keep on introducing that as the tabletop coding game, but it's a little bit more than just that. What are the key components of the game? We should definitely need to talk about that, and how can I use blocked in the classroom? And then finally, tricks and tips for successful learning experience. So with that being said, let's get started. So what is blocked? So blocked, again, is a non-computer tabletop curriculum and game activity that helps young learners or new learners better understand the essentials of developing code. Now, I always say that there is more things to learn than just what buttons to push on your keypad in order to learn how to code. Now, of course, yes, you need to learn some syntax elements and how your integrated development environment works, whether it's Scratch or Python or whatever learning environment or whatever coding structure you're trying to learn. There are definitely some syntax components that need to be learned. However, before you even get into that, you need to really think about how the computer is looking at your code. What comes first, what comes second, what comes third, and so forth. And I can't overemphasize that. So really it's learning about sequence and what should happen if you do something. So let's talk about that in turn. Plan first, write your code, then test your code. Now, what we're given the opportunity to do is plan your code and write your code here, and then we'll go in and talk about what does this look like in two different platforms. So we'll take a look at what it looks like in Scratch and what it looks like in a text-based programming language called Python. So we'll take a look at both of them. Now, even if you're experienced in code and want to learn how to use Scratch, you can do that here. Or if you've been using Scratch for a while, and Scratch is a drag and drop method, it's literally blocked elements that come in sequence. You have to know what those sequences are in order for your code to execute and actually work, because you want it to actually do something. So we're going to learn both. So that's where you're going to learn how to test your code, and whether or not you wrote it and thought about it correctly or not. That's where everything kind of comes into play. So with that being said, my motto is design, plan, and then program. So let's go forward. So what are the key components of this game? So there's a player sheet, a game board, and there's a code challenge. Now there are some additional elements that we need to become aware of, and so let's talk about them all in time. So make sure that you see in your printout that you have player sheets, at least one game board, and code challenges. For my program here, there are actually 48 different coding challenges. Now, they're a mixture of a couple of different things, but I keep the coding challenges very straightforward, very basic, because we really want to understand what the computer is trying to do and how it's looking at your code. Again, we need to learn how to think like a computer thinks. So make sure that you have at least these three elements. Once you see that on the table, let's go forward. So how can I use blocked in the classroom? Well, let's talk about what we're going to do, and then we'll talk about using it in the classroom. So there's actually four parts. There are the coding challenges, which you've just seen an example of one. There's learning how to plan your code using pseudocode. There's learning how to structure your code using a flowchart. And then, of course, it's actually solving the problem. Now, I talk about this in terms of challenges and problem solving because that's really what coding is all about. We just don't code to do something. We code because we want to do a particular something. We actually want something to move across the screen. We actually want to calculate something, whether it's a math problem or whatever. There's a problem to be solved, and the computer, learning how the computer thinks, we can use computers to solve those problems. And so that's really what we want to, again, think about is this is a problem. How do I solve it using technology? With that being said, let's move forward. So this is the introduction. Now the game is designed for 2 to 4 players. Now, what does that mean? That means that 2 players is minimum, 4 players is maximum. Can you go under 2? Probably so. If you really want to stretch your imagination and say, well, what types of code challenges are there and how do I need to think about them? I guess you can do that. That's probably a good idea. Or if you just want to play against the teacher, if the teacher wants to play against the student and see if they could actually challenge each other, that's okay too. Can the game involve more than 5 people? If there's enough room on the table, I would say yes. There are enough game pieces, code markers, and problems to solve that more than 4 people can fit into the game structure. However, that's going to be on you and your knowledge of how well your students interact with each other and how well or how ready they are to actually use the game. So we're going to talk through this as the entire instruction manual. You should be walking through this with me. And with that, let's go ahead. So the mission, of course, is to actually solve a programming challenge. And we're going to do that in very specific ways. The first thing that we're going to do is actually plan the code. So we are going to learn how to write pseudocode. This is not the instruction manual for that. There's actually there's another instructional video for each of the 48 code challenges involved in the game. So in order to know how to go about solving each of the code challenges, watch each of those videos. And those videos are not going to be any longer than 10 minutes and probably will average about 7 to 8 minutes because again, we're looking at some very basic structure elements, 1, 2, 3, and a code challenge solution will probably run about at most 8 to 9 lines of code, and at the very least 4 to 5. So we're averaging about 4 to 8 lines of code, which is rather significant. But again, some of these are repetitive elements, and some of these are just required elements. And we'll get to that as we talk about each of the coding challenges. So with that being said, we want to write pseudocode, create a flowchart, and then get through the entire game board, given its challenges, and be the first one to the finish line. So the first one to the finish line with correct pseudocode, correct flowchart, and correct code wins the game. So the game board, this is the game board, and I kind of like it. So this was an intricate design of mine, and I kind of like the way it flows, and I do like the tree elements. However, what we see here is that the game board gets placed in the center of the table. I was getting ahead of myself because I was really enthralled with my own creation here. So again, the game is designed for 2 to 4 people, 2 to 4 learners to sit around the game board at a table. And with that, they're going to have move cards and code cards. So let's take a look at those. So there are code markers. And if we go back a second, you'll see that there are circle elements and there are octagon elements on the game board. Now, a player will move his piece on each of those markers, okay? But it's really where the C marker is, the octagon, that each player wants to get to, because that's going to allow the player to take a code marker. And a code marker is just that. They hold on to these markers, just a piece of paper. And what that's going to do, it says player can write 1 line of code in the code block on the player sheet. And at the end of the game, we'll talk about having to match as many code markers there are with as many lines of code on the player sheet. without them matching line by line by line, one by one by one, we're not going to know if they may have cheated, meaning that they have more lines of code written down than they actually have code markers. And that's not what we want. We actually want to be able to verify that they collected enough code markers to write the code on their player sheet. So setting up the game board and the player pieces. So have each player choose a circle color, and we'll get to that in just a second. The circle game piece will represent the player throughout the game, and this is what they're going to use to represent themselves on the game board, and they'll use it to move space by space by space. So the game pieces are of different colors, and you could print this out. You'll need to print these out. So there's white, and this is an off shade of white over here, and there's various other colors. Now, if you want to be a bit more creative, and I'm going to think about doing this moving forward, is to put little character elements, printable character elements, that if you put or tape on a piece of cardboard, they may be able to stand on the game. However, at this point, because this is all online and interactive, so you're going to actually print these out and then use them on the table for your learners to work with. So setting up the game board, and the move cards. So what are the move cards? These are going to be the examples of the move cards, and there's a whole PowerPoint slide deck on all of those cards. Okay, so these are just examples of each, but what you want to do is place the move cards face down, and then as each player gets a turn, they're going to take the one on top of the pile and do exactly what it says. So let's take a look at what those move cards look like. So there are 4 distinct elements. There's a trap, there's a move, there's a help, and there's a finish. So let's take a look at each one of these. So trap. So again, this plays out as a game, and so the game should be fun in some way. So we don't want to just walk through all of the game board pieces from beginning to end thinking that this is all they're going to do is collect. You want to be the first person to the finish line, but you have to be able to navigate that appropriately. So the first trap is you climb a tree and to get a better look around, and now you can't get down, so you lose a turn. The second trap is you were not being careful and fell into a pit. You need help climbing out. You lose 1 turn. Now, they are the only traps where a player will lose a turn. So that means when their time comes around again in the circle, they don't get to go. The next person goes in turn. Now, with 4 players, that will actually move rather quickly. So there isn't a whole lot of frustration there, hopefully on the player's part. So my third trap is it rained for 30 minutes while you rested. Your shoes are stuck in mud. The player directly behind you gets to move to the space in front of you. So that's actually an advantage for the person behind. The next trap says a stampede of wild animals crossed your path. Get out of the way. That means you have to move back 1 space. The next trap piece says you lost track of which way to go. Switch places with the player closest to the start block. So that's significant. And then the last trap element is you get caught in heavy thickets. You cannot move forward. Go back 1 space. So there are 6 different trap elements, and you'll print multiple cards with each of those traps, and I've got that laid out in the other PowerPoint. Let's talk about the help cards. So there are some help cards that, counterbalance all of the traps. So help. Quick thinking on your part allows you to move to the space directly in front of the player in front of you. Help. Keep this card. Use it once you have fallen into the pit. You can climb out without losing that turn. So if you remember before, I said one of the traps was you fall into a pit and lose a turn. But if you have collected this card first, and there's a couple of copies of this in the move deck, you could just say, here, just return that to the deck, and you don't get to lose your turn next time out. The third help card says trade places with another player of your choice anywhere on the game board. So if that player is on one of the code markers, then you get to go to that code marker and take a code marker card. The other help card is go to a code marker specifically anywhere on the board, and take a code marker. So again, this reinforces the fact that they're trying to get to the code marker blocks in order to write their code. Without having a code marker, they can't write any lines of code on their player sheet. And then there are specific move cards. There is move 1 space in any direction and move 2 spaces in any direction. And of course, if they have not reached the finish block yet, but they have finished their code and they have one of these finished cards in hand, so they could hold on to it, and they think they solved the coding challenge, they could say, here, I want to go to the finished marker and see if my solution is correct. So they have, I think there are 6 of these in the move card deck. So setting up the game, the player sheet, and the key code. So before you start the game, make sure that the game board is on the table. Everybody has a game piece, one of those circles. And then you're going to make sure that you shuffle up the move cards and put them face down. And the code markers, they could be face up or face down. It doesn't really matter because all they are verification elements. So each player gets a code marker card because they've landed on a code marker space. But then they get a player sheet and they get a key code sheet. So they get to write on the player sheet. They should not necessarily write on the key code sheet. That's really there as a reminder of how to write flowchart elements and how to write pseudocode elements, okay? So with that, from the pile of the code challenges, have the teacher or the group decide on a code challenge, or you could randomly select a code challenge from the pile. Now the code challenge is going to be on a big piece of paper. So all those 48 code challenges that print out on your printer, each of them is its own space. So they should read big enough for everybody on the table or at the table should see them. And they are this specific. So even though there are 4 elements of the challenge, there may be more than 4 lines of code, and there definitely will be more than 4 lines of pseudocode or flowchart elements. So that's going to be taught on the back end before you play the game. But the code challenges said you need to add 2 numbers. The numbers are 3 and 4. You're going to store those numbers in variables and then display the sum of 3 plus 4 on the screen. So that's a very basic idea of what a computer can do. But again, it's learning how that is structured, what that looks like in pseudocode, what that looks like in your flowchart, and what that looks like in actual code is going to be very specific. And that's really what we want to be able to reinforce through this curriculum and through this activity. So there are 48 total code challenges within the game, and I believe I've said that already. Use 1 code challenge per game. When a code challenge is chosen and laying face up on the table, have the teacher or a player read the code challenge aloud. We want to make sure that everybody understands what it is they're trying to accomplish or the problem they're trying to solve. So before you even play the game, okay? So if anybody is unsure of what the code challenge is or what it means, the teacher really needs to step up and say, this is what we did, in class or in a previous review or whatever, and make sure that all of your learners, everybody playing the game, understands that, because we really don't want to put anybody at a disadvantage when playing the game. So please review that before moving forward and actually playing the game. So the code challenges is that thing that you want to solve. Give each student enough time to think about the code challenge. And again, if any student is unsure of the code challenge, please review it and the concepts thereof before actually starting. So with that being said, this is where we actually get going with the game. So once you have all of the pieces in play on the table, you want to go ahead and turn over the code challenge and then give enough time once you reviewed it and everybody's clear as to what the code challenge is to first thing you do is write the pseudocode, okay? Using the begin, display, store, action, decision, loop, and end structures that are in the pseudocode outline on the key code, those are the words you use to write out specifically what you think is the correct pseudocode for that challenge, okay? And that's why it's good to have for each student, a copy of the key code sheet in front of them. Now, if there isn't enough room on the table and everybody can kind of see one of the key code sheets, you only need one for the entire table. However, if the table is big enough and you can't, and all players can't see one, make sure all the players has a copy or can see at least how to write the pseudocode and the flowchart elements, because that's really important here. We really want to get the idea that there's a structure and there are specific ways of doing certain things. So with that, make sure that you give enough students, or you give enough time for all of the students to write their pseudocode. And then in the same way, once you see that all of the students have written pseudocode and maybe even have started looking at the flowchart elements, they're going to match the flowchart diagram elements, and in that bigger block area, create the flowchart, okay? So there are specific elements. There's a specific icon used for beginning and ending. There's another icon used to display, and that's more of a parallelogram. For storing information, like creating a variable and assigning that variable a number or something, we're going to use the rectangle. For creating looping structures, repetition, or making a decision, go do this or do that, we're going to use the diagram. And then of course, there's going to be the flowchart, the arrows. So the arrows will more specifically just go down. However, if there's a looping structure, that arrow needs to go back to the beginning of the loop in order to execute a certain number of times. And we'll see this more specifically when we take a look at each of the coding challenges. And then finally, you'll just tell the program that it ends. And so the same thing that you used at the beginning, you use at the end. And then we just solve the problem. We play the game. So choose a starting player. And if that's really important for the players to know who goes first, who goes second, it doesn't really matter from the perspective of the game who goes first. So if you want to do it, the youngest player or the oldest player or the person in this seat, doesn't really matter as long as there's everybody has equal access to all of the pieces to the game, and that nobody's being left out. I'm just looking at everything being equal in terms of the players having fun and this being a really good learning experience. So that player, whoever the first player is, again, picks up a move card, reads the instructions out loud, and then executes on those instructions. Now, we've already talked about all the different types of move cards there are. So again, there's trap, there's help, there's move, and there's finish. And then what we want to do is, of course, go through each of the players in turn, basically a round robin or a type of circle element till it goes back to the first player, and then you continue that sequence. Now, the only time that sequence is broken is when one of the players has to lose a turn. So we'll just skip over that player for that particular round. So we still want to play the game. Now, of course, the goal is to collect as many code markers as the player thinks is needed. And they're going to do that by landing on the octagon shapes on the game board that are marked with a C. Okay, and I think we could count them up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 or 18, depending how good my eyes are. So there's enough code markers out there for 4 players to land on. Now, again, they could go back and go forward. This isn't necessarily having to go in a straight path from start to finish. They can take any path along the game board as long as they're collecting those code markers and they're trying to be the first one done. Okay, so each player keeps the code markers collected during the game, and at the end of the game, of course, they turn everything back in so everything's collected and organized and you're all good. And again, the code markers are designed that when you have a code marker, you have, for each code marker, you have a line of code. So the code markers are simply this. So a player can write one line of code in the code block on the player sheet. To win the game, the player must keep this code marker and all code markers collected. So these are probably things that you're going to want to print a lot of, just to make sure that if any particular challenge may have on average 7 lines of code, that means 7 code markers. And if you have 4 players, 7 fours are 28, but you may actually have some that are collecting more. So again, on average, make sure you probably have anywhere from 50 on up code marker pieces of paper, just to be safe when you're playing the game. So the objective of the game is to be the first player to move from start to finish, collecting code markers in order to write all the necessary lines of code on the player sheet. So that's really it. And like I said, there's 2 ways of finishing the game. You could have the finish card when you think you have solved, or when the player thinks they have solved the code. They'd say, I've solved the code, here's my finish card, or be the first one to actually make it to the finish block. So players must know what the code looks like. And so this is really where this is just reinforcing what's been taught in the classroom, or however your learning structure is. Make sure that you're talking about pseudocode and why it's important and how it works, and talking about flowcharts and why it's important and how it works, and also talking about this is how code works. So you really have to teach code before you play the game. And my video tutorials on how to look at code, write code, and understand code is going to help you as a teacher do that before you even start playing the game. Now, the rules are pretty basic. So we've talked about needing to move from start to finish, that the move cards give the players what to do while playing the game, how to move pieces around the board. We talked about writing the pseudocode, writing the flowchart. Now, there are some specifics. Really, for this game to work well in a learning environment or a learning fun activity, you should only have one person on a spot at any one time. So there are a couple of move cards where you actually change places, or you move back and front. But let's just say for one of the move cards, it says go to the spot directly behind you. Well, if there's a person on that spot, you need to go behind that person. There's also a help card that says go move in front of the person in front of you. Well, if there's somebody in front of them, you're simply moving to the spot closest that's open, that's in front of that, in the front position. So hopefully that was clear. But again, the strategy here is to not have 2 people on any one marker at the same time. And if a player lands on a space occupied by another player, so say they have a move that says move 1, they just move ahead of that player instead of just landing on that same spot that that player is. So that's really my basic strategy when I design the game, is that there should only be one person on a marker at any one time. And there's enough ways of moving around the board that really shouldn't be a problem. So winning the game, complete the pseudocode, collect your markers, write the flowchart, write the code, get to the finish line. Tricks and tips. So just the essential elements. Everybody gets a player sheet. Everybody gets a key code sheet. Each player uses their own player sheet. Now, my thought was this: as a learning experience, have your students, have your players write their name on the player sheet. There's actually a spot in the middle that says name. So have them write their name and the challenge, because this is going to be a good way of learning what that is. So they can refer back to the challenge. So there's going to be a challenge and there's going to be a solution to the challenge, and there are different printouts. So what they should do is, if you want to just kind of review the challenges and have each of the challenges be a lesson in your classroom, that's perfectly all right. So even if you may think, well, isn't that cheating? I don't know if it is cheating. So I think everything is a learning experience, because what this really is repetition. You have to practice doing things in order to remember it and get better at it. So I think the more frequently you look at some of the coding challenges and understand what's being asked, and have your learners understand um, what the problem is, the better they're going to learn how to execute pseudocode, create a flowchart, and then write their code. So I think as more frequently, or as frequently as you can do that, given the basic challenges that are in the game, just go ahead and do that. And of course, there's a player sheet, there's a code challenge, and at the start of the game, make sure that everybody understands and sees the code challenge, and that nobody is unsure of what to do, what's being asked of them, because that will really frustrate learners, I think, who are trying to, be the first one to the finish line with a correctly written code. So they really need to understand that a lot of the code challenges require all of them require some basic things. You do need to display elements to the screen. You do need to create variables and store data elements to those variables. And either you need to be able to do a math operation or compare two things. Are they the same or are they not the same? And then finally, once we get through all of that, we really want to practice doing repetitions, or what we call loops, because we might want to do something more than once, and that's perfectly okay in any computer program. To doing things more than once is okay. So those basic elements, know how to do some math operations, real basic, add, subtract, multiply, divide, or compare two numbers, are they the same or are they different? Is one greater than or one less than? And then doing things in repetition. These are really the essential elements of coding. And finally, each player can refer to their copy of the key code to make sure that they don't forget. Again, this is all about reinforcing, learning, doing over and over and over again. So with that being said, I know this was a long tutorial, but it was a basic elements of the structure. So now let's go to the challenges. I'll see you there.